Studying one spatial diagonal conserved 1/3 roots of its cubic octrant expansion in full and stripped down cube forms. This is a full form. This is its expansion. This is the stripped down cube form. Already I can say that the outer cube form, the stripped down cube form, is conserved. It's always going to be conserved because the outside is symmetrical. The interior cube is not symmetrical, or is rarely symmetrical, unless I guess in double helix form. But it's conserved. There's 10 for the central ghost number. 6, 4, and 0 add to 10, 6, 4, and 0 add to 10. But instead of being a diagonal, a regular spatial diagonal, if I can borrow a term from linear algebra, it's a polypiped. I think that's the term where it's a volume of a vector volume or something. Combine vectors in 3 space or whatever. It's a volume that intersects the cube. This whole volume from 6, 0, 4 through the central ghost numbers to 6, 0, 4 to be 30 on all sides, being 3 of 10. So the outside's conserved as symmetrical. But that's interesting to note that in the stripped down form. And for these, this is the expansion. This is only one spatial diagonal. There's 4 possible spatial diagonals on one that's totally diverse. But this isn't totally diverse. This has a 9 and a 21, and a 9 and a 21 going on these spatial diagonals. And a 15 and a 15 and a 15 and a 15 on these spatial diagonals. One thing to note, the outside is lines. This belt-like structure goes to this cube. This is conserved. If you look at these, 10, 10, 10. Same with this inner darker gray belt structure of the cubic octrant numbers. It's conserved. 3, 3, 3, 9. Look at that. They're 3, 3, 3, and they all intersect. Same with the bottom one. Again, in a dark belt-like structure, dark gray belt-like structure with the cubic numbers. It intersects. And 777, it's conserved. But the central ghost number, it has this again, a central pyramid. This stands for a central diamond or a polypiped. Stand for the central ghost number this time. It is not totally conserved. There's 5, 5, and 0 instead of 5, 5, and 5, which wouldn't add up to 10. But 5, 5, and 0 does. But it crosses like this. It doesn't intersect. And this might hold clues to a deeper understanding of the central ghost number. Because right here, it does create the conserved 1/3, 4, 4, 4, 12. But again, it doesn't intersect like these other ones. These others are the cubic expansions of the spatial diagonal. But I believe with the study of all types of spatial diagonals, all the possible types of a certain cube, like this one, I believe, the outside would stay the same. We'd still have a redundant part, the yellow part. The outside would stay the same. The central ghost number would stay the same, or it wouldn't have a redundant part. The outside would stay the same. The central ghost number would stay the same because they're rotationally symmetrical. But this number, or this cubic expansion and this cubic expansion, these two right here and right here might differ, or in the case of a rare symmetrical form like a double helix cube, primary numbers, it might intersect, I don't know. But the central ghost number expansion doesn't play very well with the other ones. It doesn't intersect like they do. It crosses if it does give a expansion or conserved 1/3, whatever I call it, cubic quadrant, octrant numbers. And again, it's conserved on the outside because it's symmetrical, but these follow along like pipets or whatever they're called in a span. If you think in linear algebra terms, it's no longer a spatial diagonal. It's a voluminous spatial diagonal cutting through equal 36 this time on both sides, on all sides. And so this is its stripped down form. And these all go together to create the outer ghost numbers. This smaller one goes together to create the inner ghost number, the central ghost number. And this is the one that doesn't play along. Sometimes you might have where they all